Hello! In this video, you will learn how to add and subtract radicals. So we're looking at, for example, square root of 5 plus 3 square root of 5. We will be using the distributive property to help us simplify this expression. Let's have a quick review on the distributive property in case you've forgotten what it is. Let's look at the product of 2 times the binomial x plus y. We know that x and y can be combined because they are unlike terms. So in order for us to simplify this expression, we will need to distribute 2 to x and distribute 2 to y. It's like a small rainbow and a big rainbow. And then from here, you get 2x plus 2y. Now, what happens if we're given 2x plus 2y and we want to get back into the product of 2 and x plus y? So if we have 2x plus 2y, you can also apply the so-called reverse of the distributive property, the original expression. So let's see, 2x and 2y have a common factor. So 2 is a common factor. We can kind of like factor out the 2. And when you have 2x divided by 2, the remainder is x. And when you have 2y divided by 2, the remainder is y. So you end up with 2 times x plus y. So this way is what we call factoring. So it is kind of like the inverse of the distributive property. And this is what we're going to be applying to help us add and subtract radicals. Let's go back to the example of square root of 5 plus 3 times square root of 5. Square root of 5 can be rewritten as 1 times square root of 5, and 3 square root of 5 is written as 3 square root of 5. We can see that each term is made up of 2 factors, a numerical factor, 1 and 3, and we have the radical factor, which is square root of 5. So there is a common factor here, which is square root of 5 that we can kind of like factor out. And we're left with the numerical factor 1 plus 3, and we can rewrite it as 4 root 5. You can treat square root 5 kind of like a variable, something like x plus 3x. And we know that this will give us 4x. So your square root 5 is like your variable x. The same rules will apply for subtraction. And let's look at some examples to see how they work. So simplify these 4 examples. You may want to copy down the examples, try them on your own before you look at the solution. In example 1, we have 4 root 7 plus 5 root 7. Here, both terms have square root 7 as the surd, and we can apply factoring to help us simplify the sum. So I can add 4 and 5 and multiply that by square root of 7. So now you end up with a simplified expression of 9 root 7. In our second example, we have negative 12 times root 11 minus 3 times square root of 11. So from here, again, the surd or the radical term is square root of 11, and we can factor out negative 12 and minus 3 times root 11. And the answer will be negative 12 minus 3 will be negative 15 and times square root 11. In example 3, we have 5 root 80 minus 12 root 5. Here, look at the radicand. It's root 80 and root 5. We can combine terms that have unlike radicands. Our next step is to think about whether we could simplify one of the radicands so that we will have like radicands. In our lesson on evaluating radicals, we know that square root 80 can be simplified as the product of a perfect square and a non-perfect square. Now we can break up the radical term into square root of 5 times square root of 60 times 5 of square root of 5 minus 12 root 5. And root 60 is 4, so 5 times 4 root 5 minus 12 root 5. And that gives us 20 root 5 minus 12 root 5. And applying the distributive or the factoring property, you can have 20 minus 12 root 5, and that gives us 8 root 5. In example 4, we have negative 4 root 75 plus 3 root 147. So again, these two radicals have unlike radicands, so you need to simplify the radicand to the simplest form so that you can combine the two terms. And I know that 75 can be written as 25 times 3, and that kind of gives us a sense of the radicand for 147. So we can also write 147 as 49 times 3. We can apply the product of radicals property to simplify the expressions. So we have negative 4 times square root of 25 times square root of 3 plus 3 times square root of 49 times square root of 3. And that equals to negative 4 times 5 root 3 plus 3 times 7 root 3. When you multiply the rational factors, you get negative 20 root 3 plus 21 root 3. And again, we can combine the two surds by rewriting as negative 20 plus 21 times root 3, and the answer is root 3. For example 5, we have 3 times root 6 minus 2 times root 13 plus 5 times root 6. You can see that 13 is a prime number, so you can simplify the radicand further. And we do have two terms with root 6 here. So we can now combine the two terms by first rearranging them. So you have 3 root 6 plus 5 root 6 minus 2 root 13. We are applying the commutative property of addition. Move the terms around so that we can combine them. So in this case, you will end up with 8 root 6 minus 2 root 13. And the radicands can be simplified further, and they are unlike radicands, so you can combine them further, and that's the final answer. In example 6, we have 4 root 112 plus 5 root 56 minus 9 root 126. All the three radical terms are not simplified, so you have to break the radicands down into perfect square factors so that you can simplify them further. So let's look at 112. 112 can be written as 16 times 7, and you have plus 56 here, and 56 can be broken into 4 times 14. You have to realize that 7 times 8 equals to 58, but the factors of 7 and 8 doesn't work in this case because 7 and 8 are not perfect square. And let's carry on to minus 9 times square root of 126, and 126 can be broken into the factors of 9 times 14. And next we will apply the product of radical property to end up with 4 times square root 16 times square root 7 plus 5 times square root 4 times square root 14 minus 9 times root 9 times root 14. And we have 4 times 4 root 7 plus 5 times 2 root 14 minus 9 times 3 root 14. And that gives us 16 root 7 plus 10 square root of 14 minus 27 square root 14. And now we can combine the like radicands. So you end up with 16 square root 7 minus 17 square root 14, and that's the answer. We have gone over 6 examples on how you can add and subtract radicals. I hope that you have a basic understanding of how they work. And if you are ready, I have some more complicated examples coming up next. Let's go. For this next 3 examples, we have to simplify and rationalize the denominator when necessary. For example 7, we have square root 15 minus root 3 over 5. Here I can rewrite root 3 over 5 as root 3 over root 5. And now we will have to rationalize the denominator in order to combine these 2 fractions. So if you do not know how to rationalize the denominator, please watch my video on multiplying and dividing radicals to understand how we can rationalize the denominator. So in order for us to make the denominator of root 5 rational, we will have to multiply by another root 5. So that root 5 times root 5 gives you 5. And because we can change the value of whatever we're multiplying to this expression, we must make it 1. So root 5 over 5 is 1. So from here, we end up with root 15 minus root 15 over 5. Now we would like to combine the terms together with the same denominator. The lowest common denominator for both expressions will be 5. So you will multiply them by 5. So you end up with 5 root 15 minus root 15 over 5. So you end up with 4 root 15 over 5. In example 8, we are looking at the root of 2 over 7 minus root of root 7 over 2. In this case, we have to apply the quotient property of radicals to help us simplify this expression. Root 2 over 7 can be re-expressed as root 2 over root 7, and root 7 over 2 can be rewritten as root 7 over root 2. And now there are different ways of carrying out the difference between these 2 expressions, but one way that I'm going to show you here is by first rationalizing the denominator. So let's think about root 7. What can you multiply root 7 such that you can get a rational number? So we know that we can apply the property of root b times root b will give me b. So I will apply root 7 by root 7. And in order for us not to change the value of this expression, I need to put it root 7 over 7. So this value here is actually equals to 1. So it doesn't change the value of square root 2 over 7. In the second term, the denominator is root 2. So think about which radical term you can multiply to root 2 to get a rational number. So it has to be root 2. So we multiply by root 2 over root 2. Again, root 2 over root 2 equals to 1, so it doesn't change the value of the second term. Now we can start to multiply the product. So you end up with root 14 over 7 minus root 14 over 2. And we end up with the fraction, and let's go back to your properties of fractions on how to simplify this. So you have to look for the common denominator of 7 and 2 so that you can combine these 2 fractions. And 7 and 2 can be multiplied by each other to give you 14. So I will multiply 7 by 2 to give me 14, and I'll multiply 2 by 7 to get 14. So I end up with 2 root 14 over 14 minus 7 root 14 over 14. So the final answer in this case will be negative 5 root 14 over 14. In example 9, we have 3 times root 5 over 12 plus root 12 over 5 minus 1/3 root 60. So we have a lot of operations that we have to carry out here. We have to rationalize the denominator. We have to apply fraction properties or understanding to help us simplify this expression. So let's first simplify the quotient. So you get 3 root 5 over root 12. This is by applying the quotient of radicals property plus root 12 over root 5 minus root 60 over 3. In order for us to combine these three fractions, we need to make sure that the denominators are rationalized. So root 12 and root 5, you need to think about how to rationalize them. But for root 12, you can first multiply by root 12, or you can first simplify root 12. So it's up to you how you want to do it. I will first simplify square root of 12 to see what it gives us. So I have root 12 would be 4 times 3, and root 12 is square root of 4 times 3 divided by root 5, and minus 60 can be rewritten as 4 times 15 over 3. And we can see that the next step, I can rewrite it as 3 root 5 over 2 root 3 plus 2 root 3 over root 5 and minus 2 root 15 over 3. And to rationalize the first term, I have to multiply the numerator and denominator by root 3. And to rationalize the second term, I have to multiply the numerator and denominator by root 5. And I end up with 3 root 15 over 2 times 3 plus 2 root 15 over 5 minus 2 root 15 over 3. We can simplify the first term by dividing the numerator and denominator by 3. So you end up with root 15 over 2 plus 2 root 15 over 5 minus 2 root 15. And you want to combine the three fractions now. Let's determine what is the lowest common denominator for 2, 5, and 3, or find the LCM for 2, 5, and 3. And the answer will be 30. So 2 will have to be multiplied by 15 to get 30. So you multiply both the numerator and denominator by 15. For the second term, to get 30, you need to multiply the numerator and denominator by 6. For the third term, you need to multiply both the numerator and denominator by 10. And we end up with 15 root 15 plus 12 root 15 over 20 root 15 divided by 30. I'll simplify the numerator by adding 15 to 12 and minus 20. So you end up with 27 minus 20, you end up with 7 root 15 divided by 30. In our last two examples, we will be looking at the sum and difference of radicals with variables in their radicand. Simplify, assume all variables represent positive real numbers. In this case, you don't have to place the absolute value signs in the event that the variables could be negative numbers. So number 10, 4 times root 72 times s to the 4th minus 2s times square root 200 times s squared. So we can now rewrite the radical term as a product of two radicals. So we have 4 square root of 72 times square root of s to the 4th minus 2s root 200 times root s squared. And let's think about the factors of 72, whether you could break it into a perfect square factor. And you can try, and you can see that you get 36 times 2. And the square root of s to the 4th will be s squared. And minus 2s and 200 can be rewritten as 100 times 2. And the square root of s squared is s. So you end up with 4 root 36 times root 2s squared minus 2s root 100 times root 2 times s, and 4 times 6 root 2 s squared minus 2s times 10 times root 2 times s. So you end up with 24 root 2 s squared minus 20 s root 2 times s. And you have to rewrite this with the radical term or radical part on the end of the expression. So you rewrite it as 24 s squared root 2 minus 20 s squared root 2. And you could see that we have root 2 as a factor for both terms. You can kind of like factor it out now. So you will have 24 s squared minus 20 s squared root 2. Don't forget your brackets. And the answer will be 4s squared root 2. For example 12, we are looking to simplify square root of x squared over 16 plus x squared over 25. Some students will take the square root of x squared over 12, and that gives us x over 4, and take the square root of x squared over 25, and that gives us x over 5. And that's one way to simplify the expression. This is a very common mistake, and I'm going to show you why this is not correct. So if you look at, for example, square root of 3 squared plus 4 squared, if we take the square root of 3 squared, I get 3, and I get square root of 4 squared, I get 4, so it should equal to 3 plus 4. Let's look at the left-hand side. Is this equal? I'm going to put a question mark because I don't know whether they're equal. So let's look at the left-hand side. If you take 3 squared, that is 9, and plus 4 squared, you get 16. You end up with square root of 25. And square root of 25 is equals to 5. On the right-hand side, however, you get 3 plus 4, and that equals to 7. So you can see that you can just take the root of each square and add them up. So square root of 3 squared plus 4 squared is not equals to 3 plus 7. Same thing. So the part in blue, which is x over 4 plus x over 5, is incorrect. All right, so let's look at how we can simplify this root. Let me erase this work and let's start from scratch. So it's going to erase this. All right, and I know that some students don't like me to leave little markings on the board, so I'm just going to make sure that this is clean. So for number 12, you have to first simplify whatever that is under the radical sign. So there's like a brackets around that you have to simplify first. So x squared over 16 plus x squared over 25, you have to find a common denominator. And because they are perfect square, one easy way is to just think about 16 times 25. What do you end up with? And a quick calculation, you realize that that gives you 200. So 16 will have to multiply by 25 to give you 200. So I'm going to multiply the numerator by 25 to give me 25x squared. And the denominator is also by 25, so I'll get 400. And the second term, I multiply by 16 to give you 16x squared. So now I can combine the two terms. I end up with square root of 41x squared over 400. And I will have to apply the quotient of radicals property to get 41x squared over square root of 400. And now I apply the product of radicals property to give me square root 41 times square root of x squared over square root of 400, which is equals to 20. So I'll end up with x root 41 over 20. And we have gone over 12 examples. Some of the examples are really complicated and tedious, but with practice, you'll be able to do well and understand it completely. But make sure that you understand each step and how we go from one step to the next one. And on the last part, I'm going to just give you some rules that you can follow. To simplify sums or differences of square root radicals, you need to express each radical in simplest form. For example, when you have root 8 plus root 18, they may look like they have unlike radicands, but let's simplify the two radicands first. So you know that 8 is 4 times 2 and 18 is 9 times 2. From here, you can rewrite them as 2 root 2 plus 3 root 2. And now you have the two terms with like radicand. We're going to apply the next step to help us combine these two terms. Step 2, use the distributive property of factoring to add or subtract radicals with like radicands. So let's go back to the example above, and we know that root 2 and root 2 are like radicands, so we can now combine them. So we can kind of like factor out root 2, and you end up with 2 plus 3 times root 2, and that gives us 5 root 2. We have reached the end of my video. Thank you for watching. Do watch my other videos to learn more about math concepts, and don't forget to subscribe to my channel. Goodbye.